Alright, let's jump into the summarization for chapter 3, the electrostatics. So before we jump into the summarization, we have a look at the we have to recap about the prefix that we have already learned in semester 1. So we have a very small prefix that we use in this chapter. We have micro and nano. For micro, it is exponent -6, whereas for nano, exponent -9. So let's jump into the electrostatic. But before that, we are going to know the difference between Q and Q naught. For Q, it is actually point charge, whereas for Q naught, it's actually the task charge. What is the difference between these two? For point charge, I write it as PC, and for Q naught, TC, when we are going to discuss about it later. For PC, point charge is actually already in the question. Exists already in the question, whereas for test charge is actually we add into the question. We want to know what is the force or electric field strength. Alright, let's go into the electrostatic. We have about 6 major things here. Let's start with force. So before that, we are concerned about the vector or scalar quantity. When we're talking about vector, we don't need to substitute the negative into the formula, whereas for scalar, we need to substitute. It is compulsory for us to substitute the negative sign into the formula. So force is actually vector. We have for 2 points, F equals to KQ1 Q2 over R square, and F equals to KQ Q0 over R. So from the force, we need to find the resultant force when it involves 2, 3, and much more the point charge that involved in the question. If it has more than 2, more than 3, so you need to find the resultant force if the question asks you. Alright, so the first step for answering the force question, you need to check the direction. Alright, so the direction is like we have already learned before. If it is from the opposite charge, so it's going to attract. So when going to attract, for instance, we have this and this, positive and negative. So for positive, because it is attract to the right. For negative, because it is attract to the left. Whereas for the same, for instance, we have positive and positive, because it is positive, so it's going to repulse. For the right, it's going to the right. For the left, it's going to the left. Alright, as simple as that. But more complicated when it involves 3 and more point charge. Maksudnya kalau dia ada 3 dan lebih charge yang dia dah letak dalam soalan tu, kita kena tengok dulu direction dia ke mana, berdasarkan sama ada dia saling menarik ataupun saling menolak. Alright, let's go into the field strength. It's actually a vector quantity. So we have 3 formula. E equals to F over Q naught. So the electric field strength is actually measured in, so for force of course in Newton, but for field strength is Newton per coulomb. E equals to KQ over R, and when it's involved the parallel plate, we have 2 parallel plate, so we need to use this. E equals to delta V over D. Alright, so moving on, we're going to moving charge. So we're talking about the moving, we also have direction. So when it is moving, of course we know it's actually about, it has some formula that we have already learned in semester 1, which is from the kinematic. This 3 is from your kinematic. Alright, so basically it can be either positive or negative depending on the direction. If it is from negative, usually the direction will be in the opposite direction. For this case, it's going to downward. So as the displacement here, S will be negative, Sy, in Y component. So we can derive in this particular formula from F equals to ME and F equals to Q naught over E. Where this come from? E equals to F over Q naught. So we derive F equals to Q naught E. So we can derive A equals to Q naught E. So for this particular subtopic, we have zero launch angle projectile motion. We have this parallel plate, and then it's going to move in between these 2 parallel plates. So because it is zero launch angle projectile, we know that Ux equals to U and Ax equals to 0, and Uy equals to 0, but not for all of the time. We know that Uy equals to 0 when it starts from the plate. So you can use Uy equals to 0. And we have Ay equals to Q naught E over M that we have already derived above. Alright, so actually the direction can be cancelled out, but to make it clear, actually final answer can be either positive or negative depending on the direction. So always check. If it's negative, so actually it's going to the opposite direction. Is it possible? Yes, possible. So don't confuse why is it going to be negative. My lecturer said you don't have to substitute negative, but how come the answer is negative? So actually when involving about kinematic, the answer can be either positive or negative depending on the direction, because when we start from the plate and it is moving downwards, so Sy will be negative, for instance. Right, so you have to always refer to the question. Alright, let's jump into 3 last subtopics in this chapter. We have scalar quantity. So when we talk about scalar quantity, so you need to substitute the negative. Usually it's actually involving the charge, negative charge. So we have potential difference, and work done, and energy. So potential is actually measured in voltage. So V equals to KQ, here is PC over R, point charge over R. Alright, and then we have potential difference. Potential difference delta V equals to, when it is delta V, of course it is final minus initial. We have delta V equals to W over Q naught. Alright, so from these two we can actually derive W equals to Q naught times V, where V is KQ over R. So W is actually also same as potential energy equals to U equals to KQ Q naught over R. So delta U here, how we want to derive this? Let's have a look at one question. Alright, this is question 4 in our tutorial. So we have two. Here is PC, point charge. Here is Q naught, test charge. Alright, this is the value, the magnitude of the charge. Alright, from here, the distance of 40 centimeter, the question asks us to find the work done to move from, I say that this is point A to point B, where point B is actually 5 centimeter from PC. So from A to B, so we have formula, work done. So work done is actually W equals to delta V times Q naught. So WA to B is actually delta V from final, which is B minus VA, which is the initial. So delta V is KQ over R minus KQ over R. This is KQB, KQA times Q naught, RF minus R initial. So actually QB and QA, we know that it is actually Q. This is actually test charge. So we can actually factorize it. We just wrote it as KQ. KQ times Q naught times this one, we don't have, 1 over RF minus 1 over R initial. So this is the actually the equation that we will use to find KQ Q naught times 1 over RF minus 1 over R initial. So when it is positive, it is actually from external force. Kenapa kena positif? Work done ni maksudnya bila kita nak gerakkan dia tu, bila dia susah untuk gerakkan, contoh kita ada 2 point. 2 point ni dia ada positif dengan negatif. So actually force between this is actually, because it is a track, positive will be to the right and negative will be to the left. So bila dia saling menarik, tiba-tiba kita nak pisahkan dia semakin jauh, mestilah susah untuk kita buat kerja kita. Kita nak pisahkan dia dua ni yang dah lama suka sama suka. Jadi bila kita nak pisahkan dia, maka kita kena ada unsur luar, external force, untuk kita gerakkan dia. So the W will be positive. Whereas bila dia nak Bila dia jadi negatif, is actually from the internal force itself. Maksudnya dia bila dia semakin dekat ni, basically dia daripada dalaman dia. Dia orang sendiri yang mendekatkan diri dia orang. Macam itulah secara ringkasnya. Alright, so basically we want to know sedikit revision pasal force or electric field. So we have this question 3 in our tutorial question. We have 3 point charge, 6 nanocoulomb, 5 nanocoulomb, 3 nanocoulomb. Alright, so we have the direction 0.2, 0.6. It's just the same. Alright, so dia suruh apa? Dia suruh cari resultant electric field. So bila electric field, dia tengok kepada positif ataupun tak lah. Bila positif, bila satu point charge tu positif, dia actually electric field dia keluar. Whereas for negative is actually inward the PC, the point charge. So we have here is actually dia keluar, yang ni pun keluar, yang ni pun keluar. So basically dia akan, bila kita buat yang ni, disebabkan oleh dia duduk di perpenjuru, bila duduk satu dekat sini, kalau dekat awak tengok dekat yang ni, yang point 1, yang ni point 2, yang ni point 3. So sini ni saya nak buat warna purple. Alright, so satu dia ke atas sebab dia keluar, satu dia pergi ke kiri, dia keluar. So resultant dia akan jadi ke arah sini. Whereas yang sini pun dia keluar, yang sini pun dia keluar. So basically untuk point yang keempat ni, satu dia daripada sini, yang daripada yang pertama, satu lagi daripada bawah, yang third, and then dia ada yang dua punya datang. So basically kita kena tengok banyak apa benda yang saya bebel ni. Basically dia pasal bila cakap electric field, it's actually depends on the point charge only in PC. For instance, we have here is positive and here is Q0. So basically PCD dia akan ke sana. Contoh sini lah negatif. Still PC dia, point charge dia E for PC. Sebab electric field ni always respect to the PC. Maksudnya dia akan tengok PC je, dia tak kisah. Test charge tu baru kita nak wujudkan. So maksudnya dia tidak ada kaitan dengan test charge. Tapi kalau dia berkaitan dengan force, bila dia berkaitan dengan force, is actually attract lah. So this is FQ0 with respect to Q. So banyak sangat. This chapter awak kena study elok-elok. InsyaAllah dipermudahkan.